All right, so we have the align scans. Let's fix the trim lines. We will see that we have a trim line height parameter as well as a refresh button. This button will align the trim lines to the scan, while the height will decide how tall the trim lines are in millimeters. Let's pick a height and hit refresh. It will automatically place the forefoot trim lines to be 2 millimeters thick. It will then align the trim lines to the scan based on the height given. For most applications, this will not need touching up. However, sometimes there may be inconsistencies. If the arch is very high and has been misrepresented, increase the arch height parameter, then hit refresh. However, if you see a hole in the sidewall, this next section will be necessary. In the first lesson, we mentioned that objects are made of polygons, and polygons are made of vertices, edges, and faces. The curves for our trim lines are a little different. They're made up of points and handles. These handles decide the trajectory of our curves. So while our points might be in place, the handles could be altering the trajectory in a strange way, causing artifacts like this, as ideally the trimline curves will be along the surface of the scan.
To fix this, we must understand a little bit more about editing objects. First, let's select our trimline object, and then switch into edit mode. We will now notice that the points and handles of the trimline object are visible. We can select them, but how do we actually edit them? Well, there are 3 different ways we can transform these points. We can press R to rotate, S to scale, and G to grab. Each of these work by pressing the key, moving the mouse, and clicking to confirm the transformation. For our purpose of fixing the patch, we should only need to scale the point slightly to fix it. So let's try this. I want to alter this point's trajectory, so I'll highlight it, and then I'm going to press S to scale it. And as I alter this, the hole has been patched. We can now transfer back into object mode and continue editing. Note that as a beginner, I would stick to just scaling the points, as rotating and grabbing the points can be frustrating to get the hang of, and is not really needed since our trimline refresh tool will tackle most of this for us. Despite this, I would encourage you to play around with some curves for fun, and look into how these editing tools work to hone your digital design skills.
At this stage, it's looking promising. However, if we decide we want a top cover, the result may look a little strange. It will change the full length thickness and may alter the trimline result. This is because the orthotic is now working off of a larger model that you cannot see to simulate a top cover spacing. Therefore, it's imperative that we refresh the trim lines after our top cover thickness has been decided to ensure the trim lines are accurately placed. Lastly, the bevel of the trim lines and wall thickness can be decided with the following parameters. You have the choice to choose a custom taper. However, I wouldn't worry about this, as you will likely be touching these up on the grinder anyway. So leave the custom box unchecked, and the VPO pre-built bevel profile will automatically do the work for you. In the next lesson, we'll go over unilateral parameters and posting options before we export these orthoses to the printer.